Hello everyone, I warmly welcome to JKL Maths. I am Lakshmikant. Today I am going to discuss about application of trigonometry. Trigonometry has a wide range of applications across various fields. Here are some key areas where trigonometry is applied. First one, navigation and geometry. Here marine and air navigation, map making, astronomy. Second one, we use this trigonometry, engineering and construction. In this engineering and construction, building design, structural stability, bridge construction and surveying. And we use this trigonometry in physics, wave motion to read about wave motions, forces, projectile motions. Application of trigonometry we use here also technology and computer graphics to develop games, robotics and image processing. In medicine also we use trigonometry to scan CT scans and ultrasounds, reconstruction images, radiation therapy, determine angles for targeting radiation beams. Trigonometry is integral problem solving in both theoretical and practical contexts, making it cornerstone of many scientific and engineering disciplines. To use this application of trigonometry, we should know the following terms. The terms of line of sight, horizontal line, angle of elevation, angle of depression. First we will discuss about line of sight or ray of vision. If a person is, see here this diagram, if a person is looking at one object, then the imaginary line joining the object and the eye of the observer is called the line of sight or ray of view. This is called line of sight or ray of view. Now we will discuss about horizontal line. An imaginary line parallel to Earth's surface and passing through the point of observation is called horizontal line. This is the horizontal line, is parallel to Earth's surface. Now we will discuss about angle of elevation and angle of depression. Angle of elevation. If the line of sight is above the horizontal line, then angle between them is called angle of elevation. This ray of view must be above the horizontal line. This is a very important for one mark question and objective type questions. Now we will discuss about angle of depression. Here, if the line of sight is below the horizontal line, that is called angle of depression. The definition is, if the line of sight below the horizontal, then the angle between the horizontal line and line of sight is called angle of depression. Now here the angle of elevation and angle of depression is considered with the reference to the horizontal line. The height of observer is neglected if it is not given in the problem. Now we will discuss trigonometric ratios in a right triangle. Here this is the theta, angle theta, opposite side, this is the opposite side and this one is adjacent side, and here hypotenuse side. Opposite side is BC and adjacent side AB and hypotenuse AC. Here sin theta. Sin theta is equal to opposite side by hypotenuse. Here opposite is BC and hypotenuse is AC. BC by AC. Now cos theta. Adjacent side by hypotenuse. Here adjacent is AB and hypotenuse is AC. Now tan theta. Tan theta is equal to opposite side by adjacent side. Here opposite side is BC and adjacent side is AB. To solve the problems, these three ratios is enough. Now we will discuss trigonometric ratios of some angles. Sin 0 is equal to 0. Like this, we have to remember this table to solve the problem. Here also sin, cos, tan. These three ratios is enough to solve the all problems in this application of trigonometry. Now we will discuss about exercise problems. Exercise 12.1. First question. A tower stands vertically on the ground from a point which is 15 meters away from the foot of the tower. The angle of elevation of the top of the tower is 45 degrees. What is the height of the tower? First we draw a figure from the given question. Draw one vertical line from one point to distance between from a point to foot of the tower is 15 meters. Now angle of elevation of the top of the tower is 45 degrees. Draw one line from here to here. Here angle of elevation is 45 degrees. Here vertices, this one is assume A, B, C. Here we should find height of the tower AB. We assume this one is H. Now write the given data. Let AB is equal to the height of the tower H. BC is equal distance between the point and foot of the tower 15 meters. Here angle ACB is equal to angle of elevation 45 degrees. Here for this theta we have adjacent side and we need to find height of the tower. For this we use tan ratio. Tan theta is equal to opposite side by adjacent side. Here theta is equal to 45. So tan 45 degrees. Here opposite side AB is equal to H and BC is equal to 15 meters. Tan 45 how much? 1. Here H by 15. 15 is dividing LHS. If we transpose from RHS to LHS, 15 is multiply RHS value. So 1 into 15 is equal to H. 1 15 ja 15 is equal to H. So H value is 15. Height of the tower is 15 meters. Therefore height of the tower is equal to 15 meters. Now we will. A tree was broken due to storm and the broken part bends, so the top of the tree touches the ground by making 30 degrees angle with the ground. The distance between the foot of the tree and top of the tree on the ground is 6 meters. Find the height of the tree before falling down. We need to find the total height of the tree. First we should draw a figure from the given question. Here draw one vertical line. This tree is broken from this point and touches on the ground. Here touches the ground. Here this top of the tree is making the angle with the ground is 30 degrees and distance between the top of the tree and foot of the tree is 6 meters. Now we need to find the total height of the tree. Height of the tree before falling down AD. Here AD is broken part and BD is after broken part of the tree. Here AD is equal to CD. Now write the given data. Let AB is equal to height of tree before falling down is equal to x plus h. We need to find here x plus h. AD is equal to CD, broken part of the tree. We assume here x meters and height of the height before falling after falling down h meters. BC is equal distance between foot of the tree and top of the tree is 6 meters. Angle of elevation here angle ACB is equal to 30 degrees. For this tan we have adjacent side and we need to find here height. For that we use tan ratio. Here we use tan ratio. Tan 30 is equal to opposite side by adjacent. Tan theta is equal to opposite side by adjacent side is equal to BD by BC. tan 30, here BD is equal to H, BC 6 meters, tan 30 is equal to 1 by root 3, here H by 6, do cross multiplication, here 1 into 6, H into root 3, here 1 6 are 6, H into root 3, H root 3, transpose this root 3 from RHS to LHS, here root 3 will divide LHS, 6 by root 3 is equal to H, we can write like this, H is equal to 6 by root 3, here root 3 is the denominator now, so we rationalize the denominator, root 3 by root 3, if there is here root 3 now, so we need to multiply and divide with root 3. Suppose if there is root 5, we have to multiply with root 5 and divide by root 5. H is equal to 6 root 3, H is equal to 6 into root 3, 6 root 3, here root 3 into root 3, 3, H is equal to 6 root 3, root 3 into root 3, 3, here 3 1 ja, 3 2 ja, so H is equal to 2 root 3. Now we will find x value. To find x value, we use cos ratio. Cos theta is equal to adjacent side by hypotenuse is equal to BC by CD. Here theta is equal to cos 30. Theta is equal to 30. So cos 30 is equal to adjacent side. Adjacent side is 6 meters. And hypotenuse, we assume here x. Cos 30 is equal to root 3 by 2 is equal to 6 by x. Now do cross multiplication. Then root 3 into x is equal to 6 into 2. This root 3 transpose from LHS to RHS. Then it will divide RHS. X is equal to 6 2 ja 12 by root 3. Rationalize the root 3 value. Here root 3 is in the denominator now, so we should do rationalization. Multiply with root 3 and divide with root 3. Then x is equal to 12 into root 3. Root 3 into root 3, 3. 3 1 ja, 3 4 ja. So x is equal to 4 root 3. X is equal to 4 root 3. Now we found x value and h value. Then if we add these two values, then we find the total height of the tree. Height of the tree before falling down is equal to x plus h. We know the x value. X is 4, h is 2 root 3. Here 4 root 3 plus 2 root 3, 6 root 3. This is the height of the before falling down tree, height. Now we will solve third question. The third question. A constructor wants to set up a slide for the children to play in a park. He wants to set it up at the height of 2 meters and by making an angle of 30 degrees with the ground. What should be the length of the slide? Here we need to find the hypotenuse. First we should draw a figure from the given question. Draw a vertical line. Height is, this vertical line height is 2 meters. Here this slide making with the ground angle is 30 degrees. This slide is making an angle of 30 degrees with the ground. 30 degrees. Here we need to find the length of the slide. We assume this length of the slide is x meters. Here vertices are A, B, C. Now write the given data. Let AC is equal to length of the slide is equal to x meters. Here AB is equal to 2 meters and angle ACB is equal to 30 degrees. For this angle we have opposite side and we need to find hypotenuse. And to find the hypotenuse we use Sine ratio. Sin theta is equal to opposite side by hypotenuse is equal to AB by AC. Here theta is equal to sine theta is 30 degrees. So sin 30 is equal to AB. AB is 2 meters and AC is x meters. Here sin 30 is 1 by 2 is equal to 2 by x. Now do cross multiplication. Here 1 into x and 2 into 2. 1 into x, x. Here 2 to the 4. X is equal to 4 meters. Length of the slide is 4 meters. Therefore, the length of the slide is equal to 4 meters. We found the length of the slide. Now we will solve fourth question. Fourth question. The length of shadow of a 15-meter high pole is 15 root 3 meters at 8 o'clock in the morning. Then what is the angle of elevation of the sun rays with the ground at the time? In this question, height of the pole is 15 meters and the shadow length is 15 root 3. Now draw a figure from the given question. Draw a vertical line which is 15 meters. Length of shadow is 15 root 3. In this question we need to find the angle. This is a theta. We assume these vertices A, B, C. And now write the given data. AB, height of the tower 15 meters. BC, length of the shadow 15 root 3 meters. And angle of ACB, angle of elevation of sun rays with ground, theta. Here we have opposite side and adjacent side. So we can use tan ratio. We need to find here theta angle value. Tan theta is equal to opposite side by adjacent side is equal to AB by BC. Tan theta is equal to, here opposite side AB how much? 15 meters. Right here 15 meters and adjacent side 15 root 3. Here 15 root 3 meters. Here 15 1 ja 15. 15 1 ja 15. Remaining is tan theta is equal to 1 by root 3. Here tan theta is equal to 1 by root 3. Here 1 by root 3 is tan 30 degrees is equal to 1 by root 3. Here tan cancel. So theta is equal to 30 degrees. Therefore, angle of elevation of sun rays with the ground is 30 degrees. Fifth question. Now you want to set up a pole of height 10 meters vertically with the ground, support of 3 ropes. Each rope has to make an angle 30 degrees with the pole. What should be the length of the rope? Now here we need to find the length of the rope. These 3 ropes are equal length. So now we draw a figure from the given question. So this is the length of the pole 10 meters. It stands by 3 ropes. These 3 ropes are equal length now. So we take this rope for to solve the problem. We assume here this vertex is A, here B, here C. We don't know the length of the rope. So here this one is, we take this rope length is x meters. Here angle of elevation is 30 degrees. So right here 30 degrees. This rope is to make an angle with the pole is 30 degrees. Now write the given data. Let AC is equal to the length of the rope x meters. AB is equal to height of the pole 10 meters. Angle BAC, the angle of made by rope with the pole is 30 degrees. This angle opposite side is BC and adjacent side is AB, hypotenuse is AC. Here we have adjacent side and we need to find the hypotenuse. For that we use cos ratio. For this angle 30 degrees, adjacent side is AB and hypotenuse is AC. Adjacent side by hypotenuse, AB by AC. Here AB is equal to 10 meters, AC is equal to x meters. Cos, here theta is 30 degrees. AB 10 meters. AC x meters. Okay, cos 30. Cos 30 how much? Root 3 by 2. Here 10 by x. Do cross multiplication. X root 3 2 into 10. Here this root 3 transpose from LHS to RHS. Then it will divide RHS. 2 into 10, 20 by root 3. This is the one rope length. We need here 3 ropes length. Length of 3 ropes. 3 into 20 by root 3. This is the one rope length. Here 3 into 20, 60 root 3. Here in the denominator root 3 is there now, so we multiply with root 3 and divide with root 3. Here we are doing rationalization. 60 into root 3, 60 root 3. Root 3 into root 3 into root 3, 3. 3 1 ja 3, 20 ja 60. So 20 root 3. This is the 3 ropes length. Here 20 into root 3 value 1.732. If you multiply 20 into 1.732, you will get 34.64. Therefore, total length of 3 ropes is 34.64. Sixth question. Suppose you are shooting an arrow from the top of the building at an height of 6 meters to a target on the ground at an angle of depression 60 degrees. What is the distance between you and the object? Here we have opposite side and angle and we need to find the hypotenuse. Now write the figure from the given question. Here height of the building is 6 meters and distance from me and object is we don't know, so we need to find the distance here. AC, we assume AC is x meters and angle of depression is 60 degrees. Here angle of depression 60 degrees now, so angle of depression is below the line of sight, below the horizontal, then the angle between them is called angle of depression. Here angle of depression always below the horizontal line. Here alternate interior angles are always equal, so here 60 degrees na, alternate interior angle here also 60 degrees. See this two parallel lines here, this is a parallel line, this is also parallel line. If two parallel lines intersect by a transversal line, then the alternate interior angles are always equal. So here 60 degrees, so we can write here 60 degrees. Now write the given data. Here distance AC is equal to distance between me and object x meters. AB is equal to height of the building 6 meters. Now angle ACB 60 degrees. Here for this angle we have opposite side and we need to find hypotenuse. So we need sine ratio. Sin theta is equal to opposite side by hypotenuse is equal to, here opposite side AB and hypotenuse AC for the angle 60 degrees. Now sin 60 is equal to opposite side 6 meters, hypotenuse x. Sin 60 is root 3 by 2, x 6 by x. Now do cross multiplication. X into root 3, x root 3, here 6 into 2. This root 3 transpose from LHS to RHS. Here root 3 is multiplying x na. If we transpose, then it will divide RHS. 6 to ja 12 by root 3. In the denominator, root 3 value is there. So the root 3 is a irrational number. So we rationalize root 3. Multiply root 3 and divide root 3. Here root 3 by root 3. Here multiply root 3 and divide root 3. X is equal to 12 into root 3, 12 root 3. Here root 3 into root 3, 3. 3 1 ja, 3 4 ja. X is equal to 4 root 3. Therefore distance between me and object is equal to 4 root 3. An electrician wants to repair an electric pole connection on a pole of height 9 meters. He needs to reach 1.8 meters below the top of the pole to do a repair work. What should be the length of the ladder he should use when it makes an angle of 60 degrees with the ground? What will be the distance between the foot of the ladder and foot of the pole? In this question we have height of the pole and angle. Here we need to find length of the ladder and distance between the foot of the ladder and foot of the pole. Now draw a figure from the given question. Height of the pole is 9 meters. An electrician wants to reach 1.8 meters below the top of the pole. Suppose here we assume from top of the pole to here 1.8 meters and remaining subtract 9 minus 1.8, then we will get 7.2 meters. Draw a ladder from this point. The ladder makes an angle 60 degrees with the ground. Now write the points in the figure. Here A, B, C, D. Now write the given data. Let AC is equal to length of the ladder x meters. Here AB is equal to distance between foot of ladder and foot of pole is equal to y meters. BD is equal to length of pole 9 meters. BC is equal to height of the pole to be reached electrician is equal to 9 minus 1.8 is equal to 7.2 meters. For this angle 60 degrees we have opposite side and we need to find hypotenuse adjacent. First we will find adjacent by using tan ratio. Why? Because we have opposite side and we need to find adjacent. Here tan theta is equal to opposite side by adjacent side is equal to BC by AB. Here theta is 60 degrees. So tan 60 is equal to BC 7.2 meters and AB we assume y. Tan 60 root 3. Here 7.2 by y. Do cross multiplication. Here y into root 3 7.2. Now transpose root 3 from LHS to RHS. Then it will divide RHS. 7.2 by root 3. In the denominator root 3 is there now, so we rationalize the denominator with root 3 here multiply root 3 and divide by root 3. y is equal to 7.2 by root 3, multiply root 3 by root 3. Here y is equal to 7.2 root 3. Here root 3 into root 3, 3. 3 1 ja, 3 2 ja, 6. Here 1, remaining 1, 1 2, 12. 3 4 ja. Point is there now, so 2.4. Remaining values, y is equal to root 3 value 2.4, remaining 2.4 into root 3 value. Here root 3 is there now. Root 3 value is 1.732. If you multiply 2.4 into 1.732, then we will get 4.1568. Now we will find length of the ladder. Here for the angle we have opposite side and we need to find hypotenuse. So we will use sine ratio. Sin theta is equal to opposite side by hypotenuse. Here theta is 60 degrees. Opposite side BC 7.2. We assume hypotenuse x. Sin 60 is root 3 by 2. Here 7.2 by x. Now do cross multiplication. X into root 3. 7.2 into 2. Now transpose this root 3 from LHS to RHS. Then it will divide RHS. X is equal to 7.2 into 2 by root 3. Now in the denominator root 3 is there now, so multiply root 3 and divide root 3. Do rationalization. Root 3 by root 3. X is equal to 7.2 into 2, 14.4 root 3. Root 3 into root 3, 3. Here do cancellation. 3 1 ja, 3 4 ja, 12. Remaining is 2. 2. Here point is then put point. 2 4, 24. 3 8 ja, 24. So write remaining values. 4.8 into root 3 value is 1.732. Now multiply 4.8 into 1.732. Then we will get x is equal to 8.3136. Therefore distance between foot of ladder and foot of pole AB is equal to 4.1568 and length of the ladder is 8.3136. Eighth question. A boat has to cross a river. It crosses the river by making an angle of 60 degrees with the bank of the river due to stream of the river and travels distance of 600 meters to reach the another side of the river. What is the width of the river? In this question we need to find the width of the river. First of all we have to understand the question. A boat actually travels in the straight route, but because of storm it travels 600 meters from this point to this point. Flow is flowing in this way. Water flowing is in this way. That's why boat is traveled 600 meters. Water flow pushes the boat and it travels 600 meters and it reaches here. It traveled 600 meters. Now we need to find this length, width of the river length. I think you understand the question. Now draw the figure. Boat crosses the river with the angle of 60 degrees. Here boat travels 600 meters. Write the vertices. Here A, B, C. We need to find the length of the river, that is AB. We assume this one is x meters. Now write the given data. Given data, let AC is equal to distance travelled by boat 600 meters. AB is equal to width of the river x meters and angle ACB is equal to 60 degrees. For this angle we have opposite side and we have hypotenuse. We need to find opposite side. For that we use sine ratio. Sin theta is equal to opposite side by hypotenuse. Theta is angle is 60 degrees. So sin 60 is equal to AB x by AC 600. Now sin 60 is equal to root 3 by 2 is equal to x by 600. Now do cross multiplication. Here root 3 into 600, 2 into x, 2x. We can write like this: 2x 600 root 3. Here transpose 2 from LHS to RHS. Then 600 root 3 by 2. 2 is multiplying x now. Now if we transpose from LHS to RHS, it will divide. Now cancel. 2 1 ja, 2 300 ja. X is equal to 300 root 3. We found width of the river is equal to 300 by root 3. Ninth question. An observer of height 1.8 meters is 13.2 meters away from a palm tree. The angle of elevation of top of tree from his eyes is 45 degrees. What is the height of the palm tree? We need to find here height of palm tree. We have height of observer 1.8 meters, distance is 13.2 meters and angle is 45 degrees. Now draw a figure. Now we assume this is a palm tree height. We assume this is height of the boy or observer. Height of observer is 1.8 meters. The distance between observer and palm tree is 13.2 meters. 13.2 meters. Draw one horizontal line from up here to here. The angle of elevation of the top of the tree from his eyes is 45 degrees. This is parallel to surface. So both are length of this equal. So write here 13.2 meters. Here also these two lines are parallel. So write here 1.8 meters. Now write the vertices names: A, B, C, D, E. In this question we need to find the height of the palm tree. So here we need to find, we know the CD and we need to find here DE. Then we add DE plus DC. Then we will get the height of the palm tree. We assume here DE is x meters. Now write the given data. Let DE is equal to x, AB is equal to height of the observer is 1.8 meter and BC is equal to distance between the observer and palm tree is 13.2. Here AB is equal to CD is equal to 1.8 meters and BC is equal to AD is equal to 13.2 meters. Here angle EAD is equal to 45 degrees. For this angle we have adjacent side and we need to find opposite side. So we will use tan ratio. Tan theta is equal to opposite side by adjacent side. Here tan theta is equal to opposite side by adjacent side is equal to DE by AD. Here theta is 45 degrees. So tan 45 degrees is equal to, here DE is x meters and AD is 13.2 meters. Tan 45 value is 1. Here x is equal to 13.2. This 13.2 transpose from RHS to LHS. Then it will be multiply 1. Here 1 into 13.2 is equal to x. X is equal to 13.2 into 1, 13.2. Here DE is nothing but x. X is equal to how much? 13.2 meters plus DC 1.8. 13.2 plus 1.8 is equal to 15 meters. Therefore, height of the palm tree is 15 meters. 10th question. In the adjacent figure, AC is equal to 6 centimeters, AB is equal to 5 centimeters and angle BAC is equal to 30 degrees. Find the area of the triangle. Here, to find the area of triangle, we draw a perpendicular from B to AC. Here this point, name it as D. Now write the given data. In triangle ABC, AC is equal to 6 centimeters and AB is equal to 5 centimeters. Let BD be this BD be the perpendicular drawn from point B to AC. Then angle ADB is 90 degrees. So in right angle triangle ADB, we can find BD length. Here BD is the height by using sine ratio. Sin theta is equal to opposite side by hypotenuse. We assume BD is x centimeters. We have hypotenuse and we need to find opposite side. So here angle is 30 degrees. Sine 30 degrees is equal to BD is x, hypotenuse AB 5 centimeters. Sine 30 is equal to 1 by 2, x by 5. Now do cross multiplication. Here 1 into 5 is equal to x into 2x. We can write like this, 2x, 5 1 ja 5. Transpose 2 from LHS to RHS. Then it will be divided 5 by 2. 2 1 ja 2 2 ja 4, 1. So point 1 is not possible now, so keep point 1 0 10. 2 5 is a 10. We get x is equal to 2.5. So we got height. Height is 2.5 meters. We need area of the triangle. Area of the triangle is 1 by 2 into base into height. We have base and height. Area of the triangle half into base B into H. Here base AC is first write 1 by 2. Here base 6 centimeters. Base means AC. Height, we got height 2.5. Now cancel 2 1 ja 2 3 ja. So 3 into 2.5 7.5 centimeters. Area of the centimeters square. Area of the triangle is 7.5 centimeters square. Thank you for watching. Please subscribe my channel. Share this video with your friends.